Alright, hi everybody. So this is our last chapter for the year. This is organic chemistry. So one of the things that people have difficulty with or struggle with at first is whether or not something is organic. And unfortunately, in our lives, organic, the term is used to mean or have different meanings. If you go to the market and you buy some strawberries or some other kind of fruit or vegetable or pretty much any item at this point, it is labeled as organic or not. And in chemistry, that has a different connotation than what you're used to thinking about, in the supermarket. And with organic, when we study it, we look at whether or not it has carbon in it. And in order to be organic, you need to have carbon, the element, in the compound. Now, not everything that has carbon in it can actually be considered organic. And I'll show you, some examples of that where it is not. But something like butane contains this compound here. It has 4 carbons, and it has 10 hydrogens coming off of it. This compound contains carbon, and it is considered to be organic. When we look at water, although water is really necessary for reactions, including organic reactions, it doesn't have the carbon in it, and so it is considered to be inorganic. Something like plastic is generally made up of a compound called PVC. This stands for polyvinyl chloride. And what I'd like you to do for polyvinyl chloride is look up what the structure is and come back and tell me, is polyvinyl chloride, is that organic? And then we have caffeine as well. Look up the structure for that and come back and tell me if in fact it is organic or not. So if we were to look at these different structures, so we have PVC, we have polyvinyl chloride, and caffeine, go ahead, look them up. Let me know if they're organic or not, and we'll talk about that tomorrow. So when we talk about organic chemistry and studying it, again, it relates to that compound of carbon, or that element carbon, and the compounds it forms. And so that's really what organic chemistry is. It's the study of carbon-containing compounds. And their reactions. Superficially, we're interested in things like naming the compounds, we're interested in their properties, but if you were to take an organic chemistry class actually in college, what you would see is that they're interested in the reactions. That's what they care about. And we'll spend a little bit of time on the reactions, and we'll go into a little bit more detail than I would in a Regents class, but this is just sort of scratching the surface. So what are some types of organic compounds? Well, there's the general and most basic type called hydrocarbons. Now, hydrocarbons, those contain just carbon and hydrogen. And then there's other types of organic compounds, such as alcohols that have an OH group attached to them, esters that have a carbon attached to 2 oxygens, like this. We also have acids, carboxylic acids they're called, that have a structure like this. This is a carboxylic acid. We have ketones, where you have a C double bonded to an O. And if you want a more complete list, you can always look on table R and get a more complete list of the different types of organic compounds that you could find. Now, when we look at organic reactions, one of them you actually already know. One type of really common organic reaction is called combustion. But there are other types that you may or may not know. One that is related to bio is something called fermentation. The process of making soap is called saponification. Whenever we try and make a large molecule from a small molecule, it is called polymerization. Now, in order to understand some of these reactions and how some of the compounds behave that we're going to discuss, the hydrocarbons, the ones that have alcohols, esters, ethers, we need to also understand the properties of the compounds. And so what are some common properties of organic compounds? Well, they are, first of all molecular. Molecular compounds will generally have lower melting points. They will have lower boiling points. They'll tend to be soft. They'll tend to have slow reactions. They tend to be, but not always, insoluble in water. And that means that they are nonpolar. Now I say this and then I sort of bite my tongue at the same time, because this describes a majority of the compounds that we see for organic compounds. But there are a whole host of organic compounds that are polar and are soluble in water. These tend to be the ones in these groups. They tend to be the alcohols. They tend to be the organic acids, the ketones, the esters. Now look, this gets complicated because I could show you an alcohol that is soluble in water, and then I could show you another alcohol that is not soluble in water. And in class, we really need to discuss this. What's the deciding factor, whether something is polar or nonpolar? These organic molecules, I do this at the end of the year because they're complex. Sometimes they have a lot of carbons on them, sometimes they don't. Let me show you a quick example. If I were to take something like CH3OH, this is an alcohol. We haven't learned how to name it yet. This has one carbon on it and this OH group. So this is going to be soluble in water. It's soluble in water because it can form those hydrogen bonds with water. And the chain of carbons, the carbon chain, is small. But when I look at this molecule, it really has two parts. It has the CH3 part, and it has the OH part. And each of those parts convey a different property. The CH3 part tends to be nonpolar, and the OH part tends to be polar. But the nonpolar part is small enough that it's not really affecting the overall properties. Now imagine if I showed you an alcohol like this, where I have a whole chain of carbons. Now this has a big nonpolar part right down here. So now it has this whole nonpolar part right over here. And it still has the polar part over here, don't get me wrong. But now look at the nonpolar part. This nonpolar part compared to the polar part is much bigger. If I were to try and dissolve this in water, well, guess what? It's still an alcohol, but it's insoluble at this point. So as you can see, it's complex because it has both of these types of properties, and we need to decide what's more important. Really, the only way that you can do that, besides guessing, the really only way that you could do that would be to actually test it out. Put some of this in water and see if it dissolves or not, and that will give you an idea if it is overall polar or nonpolar. Now let's talk about this last slide here, some applications. Organic chemistry, when you go to college and you study this for an entire year, this is an entire year course in organic chemistry. It actually comprises 2 separate courses and a lab that lasts an entire year. That's also a 3rd separate course. You sort of are setting the basic knowledge for doing more advanced studies. And organic chemists, the ones that specialize in organic chemistry, they go on to do some pretty phenomenal things. One thing is drug development. When we talk about pharmaceuticals, the development of new antibiotics, the development of new painkillers, the development of new cancer treatments, heart disease therapies, all of these come from a chemist working on a compound and trying to change it. And there's this whole field called rational drug design. Rational drug design. And rational drug design, it takes an existing compound and it changes the chemistry of it, what they call the functional groups. And you'll see what functional groups are. And when we change the functional group, that will change the way that the drug works and hopefully make it more effective and less toxic. Another field, cosmetics. Here on Long Island, there's a big cosmetic company, Estee Lauder, and they're located in Melville, and they have a huge research lab. And they're trying to research what are the best types of cosmetics to use, ones that are long-lasting, non-toxic, hypoallergenic. Now, a chemist's job in the cosmetic industry got a lot more difficult recently, in the last 20, 25 years, because originally people used to, unfortunately, test cosmetics on animals to see if they were toxic or see what type of damage they would do. And this really raised a lot of ethical questions. How could you treat an animal that way, just so that somebody can look nice? And so they've had to develop different approaches in which they can test cosmetics without actually harming other organisms. And finally, food chemistry. Food chemistry is really important because, you want that food to stay fresh and you want it to taste great. And these big food companies like Kellogg and Procter & Gamble, they have a huge section that's called research and development, R&D. And they have chemists who are trying their best to get food to stay fresh as long as possible, taste as good as possible, be as nutritious as possible. And sometimes this could go wrong. If you manipulate a food to such a point, it takes on, like something that may not even resemble food. And the food chemistry industry and the food industry has come under a lot of scrutiny lately because of the idea that we're altering the foods that we eat so much that eventually they lose their natural food properties. So this is some background on organic chemistry. The next video that I'm going to do with you will talk about types of formulas, and we'll really get into naming hydrocarbons. All right, thanks so much for watching.